So we looked at case 1, the straightforward way of solving for an oblique triangle given two angles of a triangle, whether it was the situation in which you had angle, angle, side, or whether you had angle, side, angle. It was pretty easy for us to solve for the third angle and therefore use law of sines to solve for the remaining sides. However, when we're given only a single angle, like the case that we see below called side-side angle, we have side-side angle is, when spelled backwards, sometimes considered a pain in the butt to solve. Okay, so the results of being given a side, and an angle is the word ambiguous means that it is unclear whether you might or might not have a triangle that fits that those initial parameters, or you might have one triangle, or you might have two triangles. So to illustrate this, I had linked an applet on the agenda that I'd like you to open up. I'm also going to simultaneously open up that applet and then just give you guys a visualization of what it means to have two triangles, one or no. So remember that you're given a side, and a non-included angle. So let's go ahead and pull up the triangle here. So this is the GeoGebra applet that you see. What I'm going to note is that angle A is given to you as 30 degrees. Side B is given to you as 9, so that's angle. And then you have a side, and then the third side is given. And say that the third side happens to be a length of 3. You can see that no matter how we swing that third side, this does not form a triangle. So this is an example of what happens visually if you're given a side, and an angle, and no triangles can be formed from the initial parameters. However, if you extend A just a bit more to a length of 4.5, and it's going to take me a minute to get this right here, 4.5, we see that 4.5 is the perfect length to form a single triangle with a parameter of angle A being 30 degrees, side B being 9, and little a being 4.5. So the triangle can exist if A is long enough to form that second side. So you'll notice that it says angle B at the bottom. So in this situation, you'll end up with a single value for angle B, a single value for angle C that you're going to solve for, and then a single value for side C, little c. Now, so we looked at what happened if the side length was less than 4.5. When it was 3, no triangles existed. When it was exactly 4.5, it's a perfect length to form one triangle. And then if it's more than 4.5, say 5.3, if I swing that third given side, A, 5.3, it forms either the segment CB1 or the segment CB2, both of which are congruent to each other. So now the results of this is that you have two triangles that are formed. The first triangle has B1 as an angle measure. So AB1C is an obtuse triangle versus another triangle that could exist from the side length A being 5.3 is AB2C, and that is a scalene triangle. And so what you see is that you have two possible answers with a side length of 5.3. And this is the reason why it's ambiguous. It all depends on the dimensions that you were given to begin with, whether that is you're able to form a triangle from it, no triangles, or two triangles.